In this video, we are going to solve some 5 questions from the chapter Algebraic Expression, class 8. Let's begin with the first part. Here we have to find the product of these two binomial, right? So as you can see, it does not fits into any of the identities we know. Therefore, we are going to apply the distributive property for multiplication. So I'll multiply this 3m with this whole of the second binomial. This is 2m minus 3n. Similarly, we'll multiply now 2n multiplied by 2m minus 3n. Now check here, if I multiply these two, it will give you what? 3 into 2, 6, m into m, m squared. This multiplied by this, minus 9mn. These two multiplied to give 4, m into n is mn. And this into this is again, this is 6n square. Now check here, this is 6m square and these two are like terms. So what is minus 9 plus 4? It is minus 5. So minus 5 times mn and minus 6n square. So we'll say that this is the final answer for this. Question number 2 is to evaluate this, but by using identity. So first of all, what I can see that I can write 102 as 100 plus 2. Why 100 plus 2? Because we need to obtain the maximum 0. So I just wrote 102 as 100 plus 2. Now we can clearly see from here the identities applicable is a plus b whole square, which is a square plus 2 times ab plus b square. Well, a is 100 and b is 2 here. So we can write this as a square, that means 100 square plus 2 times a, which is 100, multiplied by b, which is 2, plus b square, that is 2 square. So 100 square is what? As you know that once finding the square, the number of 0 become double number of zeros. So 2 zeros become 4 zeros. Now 2 into 2 is what? 4 multiplied by 100 is 400 plus 2 square, which is 4. Now if I add it, it's going to be 4, 0, and then 4 here, 1, 0. The third question is to find the value of this expression. Now, as you can see, they have not asked or restricted us to use any identity. So we'll be simply replacing x with minus 1. So this is 25 times minus 1 square plus 70 times minus 1 plus 49. So minus 1 square is 1. 1 multiplied by 25 is 25. 70 into minus 1 is minus 70 plus 49. Now what you can see here that if I add these two first, I'll get 74 minus 70. So finally, we'll say 4 is the answer for this. Question number 4 is to simplify this. Now check here, it fits into an identity. Let me write down the identity, better known as third identity. So it's a minus b into a plus b is equal to a square minus b square. All right. Now we have to, and conversely, we can say a square minus b square can be written as a plus b into a minus b. So what I can write this, I can write this as 1.62 the whole square. And this I can write as 0.38 whole square. Now you see, what is a square minus b square? A plus b into a minus b. Considering this to be a and this to be b, I'll write this as a plus b multiplied by a minus b. Now check here. This is the, if you add this, you are going to get 2 here, right? And if I subtract, that is, if you subtract from 1.62, if you subtract 3.8, right? No, 0.38. So 1.62 minus 0.38. 2.38. So it will give you 1.24. Now, if you multiply, this will be double of this, 248 and 2 decimal place. So we'll say this is the answer for this part. In this question, number 5, we have to simplify this or find the value of this. So again, this is based on the same identity, that is a plus b multiplied by a minus b is equal to a square minus b square. Now check here, I'm going to apply this identity only in this pass first. So if I consider a as a and b as -1, so a plus b into a minus b is a square minus b square. So I can write this as a square, that is 1 square, minus b square. B is 1 here, so 1 square. As you know, 1 square is 1 only, so you may simply write 1. Now, I'll copy this term, which is a square plus 1. Now check here, again, we can apply the same identity over here. This time I'm going to consider this as a. I'll consider this as a and this as b. So you can see it is a plus b into a minus b. The order does not make a difference, as you know that, whether you write this or this first. So this will give you a square. Well, a is this and its square is this, minus b is this and square is 1 square. As I said, 1 square is 1 only. So you can now say that a square whole square is a raised to the power 4 and minus 1. So therefore, we'll say this is the simplest form, or after finding the product, we'll get this.